Hi, hello, good morning. This is Maruti Prasad Satluru. Yes, hi, hello. Yes, hi, hello. Nice, all of you. Welcome to Unacademy YouTube channel, all of you. This is your Smarty. Yeah, Anish, good morning. Very good morning, Anish. How are you? Yeah, Usha, very good morning. And what about the remaining? Anyway, let us start. Anish, are you ready? Anish, are you ready? Usha, Anish, are you ready or not? Yes, very good, very good. Nice. Yeah, right, Anish. Very good morning, one and all. Welcome to Unacademy YouTube channel. Right, if you are taking, if you are already taken a subscription, plus subscription, there is no problem at all. Otherwise, better to take the plus subscription. Why? Because there is a lot of benefit for you. If you take the plus subscription, you may get so many number of benefits. Out of which, with the affordable price, premium content will be there. Okay, and the structured live courses are also will be there. Structured live courses along with doubt clearing sessions. Of course, in the YouTube live channel, we will clarify your doubts. There is no doubt at all. But along with this, if you take the subscription in the plus classes, we will clear all the doubts after completion of the concept. And in regular intervals, there are some quizzes for getting self-analysis of yourself, and some batches for complete preparation also will be there, and so many number of mock tests will also be conducted with full type of analysis, right? And for single subscription, for unlimited access. Okay, everything under a single subscription, and this entire Unacademy is having 20 plus for TS and AP MCET. Top indicators are there, 10 plus batches are going on, 250 plus courses are also already been saved, and 2000 plus lessons are also have been saved. So it is very benefit for you once you are taking the plus subscription. If you want to take the subscription, this is the link. See here, this is the link. And if you want to take the subscription, use my code, that is Maruti Live. And for 2021 aspirants, I think you are all 2021 aspirants. Yeah, Vasha Reddy, good morning, very good morning. Devendra Reddy, all of you, very good morning, one and all. So for 2021 aspirants, sir, do you take special classes on record? Yeah, I'm taking the special classes as well as plus classes also. Plus class and special class also I'm taking, right? For 12 months plan it is 12,375, and for 6 months plan it is 10,175. 10,175. These are the, yeah, right. Multiple batches are going on now. See, use my code, that is Maruti Live, and two important comprehensive batches are also going on with the top indicators, you know very well. Yeah, see Anish, here is mine. Here is mine. I am also one of the educators in Unacademy for TS and APMC 2021. Okay. If you want to listen my classes daily at 6 to 7, daily night at 6 to 7, I have a special class, and plus class also at night. Okay, right? Just a recapture of the previous session, that is chemical equilibrium. So in the part 1 we have discussed about the irreversible reactions and reversible reactions we have already seen. And irreversible means only the forward reaction or only the backward reaction will be possible, but both the reactions cannot be possible in the irreversible reactions. Already we have seen, and we have learned so many number of examples for irreversible reaction also, right? And if you take the reversible reaction, in this case, you know very well the forward reaction as well as backward reaction. Both reactions can be proceeds in the reversible reactions. And we have seen all the important examples for reversible reactions also, right? Good. See, there are some important differences in between reversible and irreversible reactions you have. So, what are the important differences in between reversible and irreversible? It is very important to you to opt the objective weights with respect to MCET point of view. What are the main differences in between these two? I have given only a brief differences in between these two. These are very important to you with respect to MCET point of view, right? So, please observe carefully. It is only one direction. Irreversible reactions can be done only in one direction. But suppose if you take the reversible reactions, These can be done in opposite directions. That means forward reaction as well as backward reaction. Both can be possible in the reversible reactions. Okay. At the last of this session, you will have multiple choice questions. You will have multiple choice questions. Let us see what type of multiple choice questions will be there in the last session. Okay. Right. And see here, this is also one most important point with respect to multiple choice question. What is this? These reactions, that means either forward or backward reactions will go for almost completion. For almost completion, that means all the reactants are completely converted to the products, or all the products are completely converted to the reactants. That means these reactions will go for almost completion. And the reactions, suppose if you are observing the reversible reactions, these never go for completion. It is very important objective bit. Reversible reactions are in chemical equilibrium. That particular reaction never go for completion. It is very important. We are saying, we are assuming, we are concluding that that reaction is over. We are concluding, but it is not correct. The reaction will proceed continuously when the time is going on. When the time is going on, the reaction can never go for completion. That is the important point with respect to reversible reactions. And it is very simple question. This point is not very useful, very helpful for us. Of course, it is having only an arrow like this. That means either forward reaction or backward reaction. Only one arrow you need to keep in between the reactants and product side. Either forward reaction or either backward reaction. Simply you have to place only one arrow. But in this case, a sign should be placed. What is the sign here? It is a half hooked arrow. It is called as half hooked arrow. It indicates reversible reaction. That means forward reaction will proceed, backward reaction proceeds, but the reaction never go for completion. Please don't remember, please don't confuse at this particular point. You have to remember this reaction, the reversible reaction, the reaction will never go for completion. Please keep this point in your mind. Right? Good. Come to the next one. Equilibrium is not possible since it is unidirectional. Equilibrium is not possible. In the reversible reaction, no equilibrium will proceed. Why? Because either only forward reaction or either only backward reaction will proceed. So once you are saying that only either backward reaction or forward reaction will proceed, we cannot say the equilibrium will not be attained for irreversible reaction. Then what about the reversible reaction? Definitely it is possible. For reversible reaction, equilibrium will be possible, equilibrium will be attained at the reversible reaction. Okay. Yeah, Anish, almost both are similar. Both are similar, but NCERT is having some more just a concept. A small additional concept will be there, but both are similar. Almost both are similar. You can read either NCERT book or either you can read Telugu Academic. Both are similar. Both are one and same. So equilibrium may be attained. Equilibrium may be attained in the reversible reactions. In the reversible reactions, it will be attained, right? And coming to the examples for irreversible and reversible, in the last case already we have seen all these important examples, right? Is it right or not, Anish? In the previous case, in the last class, in the last session, we have already seen all the examples for reversible as well as irreversible reactions. Is it right or not? Yes. These reactions we have already seen. And these two graphs also we have been discussed in the last session. See, when the time is going on, what about the concentration? Yes, sir, you told many examples. Yeah, very good. Pujaridi. Good morning, very good morning, Pujaridi. Thank you for coming to my channel, to my session. Thank you very much. Right, very good. See, when the time is going on, the concentration will be reduced. See, the A and B are reactants here, and C and D are products here. Product concentration will be increases, reactants concentration will be decreases. And at a particular time, once time is going on, then both the reactants and products will attain the equilibrium. Okay. See, the time of the reaction is taken on x-axis and the rate is taken on y-axis. If you plot the graph in between the reactants and products, the forward reaction will be decreases, rate of the forward reaction will be decreases, and rate of the backward reaction will be increases, and it will attain an equilibrium state at a particular time. Then you may ask some doubt. Sir, how do we know? How do we know whether the equilibrium state has been attained or not? How do we know? Is there any measurement? Is there any measurement? Sir, for concentration versus times, other two graphs are also possible. Yes. For other two graphs, no, only one thing is possible. Only this graph is possible with respect to concentration and time. Only one important graph will be possible. But the second one is not for the concentration time, it is with respect to rate as well as time. That's Avinash. Right, good. Yeah, Arvind, very good morning. Very good morning, Arvind. Welcome to this Unacademy YouTube channel, all of you. Very good, very good. Nice. Thanks for coming, all of you. Anyway, see, once the time is going on, what about the rate of the reaction? Forward reaction rate will be reduced. Why? Because reactants are there, products are there. Once the time is going on, all the reactants are slowly converted to products. So, what about the rate of the reaction? Slowly it will get reduced, and slowly the concentration of the products will be increases. Concentration of the products will be increases. Then once you are increasing the time of the reaction, the backward reaction will proceed. So the backward reaction will be increases. Rate of the backward reaction will be increases. Okay. But you may ask some doubt. Yeah, Adurti Ratnam's kitchen. Anyway, welcome to Unacademy YouTube channel, Adurti. Very good morning. Very good morning. So, you may ask me some doubt. Sir, how do we calculate, how do we measure whether the equilibrium state will be attained to a reversible reaction? You know very well, only for reversible reactions, equilibrium state will be attained. Is it right or not? Yes, it is right. But how do we know? What is the measurement step to calculate or to know whether the equilibrium state has been attained or not? That is our question. Yes, simply there is a particular experiment to know whether the equilibrium state has been attained or not. Okay, how do you know how to do the particular experiments? See, this is a basic experiment to know whether the equilibrium state has been attained or not. Very important example, very important experiment also. From this, definitely one question will be there from MCET point of view. No doubt about it. You have to take more care on this. You have to pay more concentration on this. You have to keep all these concepts in your mind, right? See here, I am taking N2O4 and I am taking NO2. There are two different type of substances here. One is nitrogen tetroxide, second one is nitrogen dioxide. N2O4 and O2. Out of these two, one substance like N2O4 will be placed in A. See here, it is a vessel. In this you have to fill the N2O4. It is another vessel. In this you have to fill the NO2. Okay, you have to fill the N2O4 as well as NO2 in both the vessels. In both the vessels, you have to fill the N2O4 in one case and NO2 in other case. See, I am giving a small concept to you. N2O4 is colorless at lowest temperature like 0 degrees Celsius. And NO2 is having reddish brown color at elevated temperatures like 100 degrees Celsius. Right? So, at high temperatures, NO2 is in reddish brown. And at low temperatures like 0 degrees Celsius, N2O4 is colorless. Okay, right. You know very well there is a equilibrium, there is a reversible reaction between these two. See, suppose if you take N2O4, if you heat N2O4, it will produce the 2NO2. It will produce the 2NO2. Are you understand anyone? Is it understand to all of you or not? Is it understand to all of you? Are you following my lesson or not? All of you. Yes, right, very good, very good. Then it is okay. Then it is okay, all of you, please. Yeah, good. See, listen carefully. Yeah, right, very good, very good. Thank you. Listen carefully. I am taking N2O4 in A and I am taking, yeah, hello Praveen Kumar, hello. Welcome to Unacademy YouTube channel. Hi, good morning, very good morning. And if you are taking NO2 in B vessel, I am taking these two. Then you have to keep the A, in ice bath. That means it is approximately 0 degrees Celsius. And you have to keep the B in which? In boiling water. That means approximately 100 degrees Celsius it is. You know very well at elevated temperatures it is in reddish brown now. And it is in colorless. N2O4 at 0 degrees Celsius it is in colorless. And at 100 degrees Celsius in boiling water, if you place this, it is in reddish brown. So now these two vessels are having colorless as well as reddish brown respectively. So A is having colorless, B is having reddish brown, right? Now, listen carefully. Now, I am taking the colorless as well as reddish brown. These two vessels and I am placing these two in room temperature. That means I am placing it in water at 25 degrees Celsius. At 25 degrees Celsius, then what will happen? Once you are placing these two vessels at 25 degrees Celsius, that means at room temperature. Yeah, Tarun Kumar, hi, good morning, welcome to Unacademy YouTube channel. Thanks for coming. So whenever you are placing these two vessels at 25 degrees Celsius, what will happen? See, a magic will be going on. A magic will process. What is that process will be going on here? You know very well it is a colorless normally. Why? Because you are placing that entire N2O4 at 0 degrees Celsius. The main concept of N2O4 is colorless at 0 degrees Celsius. You know very well. But you are placing the 0 degree. You are changing the temperature from 0 degrees Celsius to 25 degrees Celsius. Whenever you are changing that from 0 degrees, what is the conclusion of this experiment, sir? Yes, I am saying the conclusion. Attainment of the equilibrium is the conclusion. Attainment of the equilibrium is the conclusion. Anish. So whenever the 0 degrees Celsius is reaches to 25 degrees Celsius, what will happen? Slowly the temperature will be increased. So this colorless is slowly increased to pale brown now. Slowly the colorless substance, the A, will turn to pale brown. In the same way, whenever you are placing the B vessel into this water at 25 degrees Celsius, that means you are reducing the temperature from 100 to 25. From 100 to 25. Yeah, Sachinarayana, good morning. Very good morning. Welcome to Unacademy YouTube channel. See, from 100 to 25 degrees Celsius, whenever you are reducing, the reddish brown is slowly turns to colorless. That means the pale brown will color appears at 25 degrees Celsius. So, this A will turns to pale brown. This B is also will turns to pale brown. Got it, Anish? Right, very good. So at this 25 degrees Celsius, both N2O4 is turns to pale brown and both NO is also turns to pale brown. Now the NO2 as well as N2O4 are getting an equilibrium state. They are reversible reaction and the reversible reaction is now at in equilibrium state. So we can conclude, yeah, this my reversible reaction is now in equilibrium state. That is the conclusion. So in such a way, that means what is the constant here? Anish, can you guess? Anish, can you guess what is the constant here? Which parameter is constant here at equilibrium? Anyone, not only Anish. Anyone, please, can you give the correct option for me? Please give the correct option for me. At any stage, that means at 25 degrees Celsius at this room temperature, which parameter is to be constant? Which parameter is constant now? No, not concentration at all. Not concentration at all. See, it's a physical property. It's a physical property. This colorless is turns to pale brown and reddish brown is also turns to pale brown. That means the color is constant at this 25 degrees Celsius. Color is constant. So, if you are taking any reversible reaction, I am giving the conclusion to you. If you are taking any of the chemical reactions, reversible reactions, in all the reversible reactions, we can conclude the attainment of the equilibrium only with the help of color or only with the help of density or only with the help of pressure, right? So pressure, color, density, these are all the parameters by which only we can measure or we can conclude whether the chemical equilibrium has been attained or not. Is it clear now? I think I am clear and it is also clear to you also, right? Good, very good. Nice. Coming to the important characteristics of equilibrium, very important. These are all very important for you. Characteristics of chemical equilibrium. What are the different characteristics? Once the reversible reaction has been attained, this equilibrium, you know very well whether the equilibrium has been attained or not. With the help of color, you can measure. With the help of pressure, you can easily measure. You can conclude. With the help of density, also you can conclude. Right? You can conclude and you can know whether the equilibrium has been attained or not. Right? Once the equilibrium has been attained, if you observe the chemical reaction carefully, so many number of characteristics are there for that equilibrium condition. What are they? See here, both forward as well as backward reactions are continue to take place in a reversible reaction. There is no stop at all. There will be no stop at all. That means the chemical reaction never go for completion at equilibrium state. Yeah, minimum 2 to maximum 3 Aduti. Minimum 2 to maximum 3 problems will come, definitely there is no doubt at all. From chemical equilibrium, the minimum 2 to maximum 3 questions will come. Okay, from in the MCET point of view. So both forward and backward reactions will continue to take place in a reversible reaction. This is one important concept. That means the completion will never go. The chemical reactions will never go for completion. That is most important sentence you have to keep in your mind. And see here, at equilibrium state, the rate of forward reaction is equal to that rate of the reverse backward reaction. Rate of forward reaction is equal to that of the reverse reaction. That means the backward reaction. So rate of forward RF is equal to rate of backward RB. So RF is equal to RB at equilibrium state. Both the rates are equal. Forward rate is equal, backward rate is equal. That's why the graph is looking like this. See, at the equilibrium state, both the rates of forward and backward are equal. Here RF equals to RB. Both the rate of forward as well as backward reactions will be equal. Good. Coming to the next important point. All the reactants and all the products of the reaction are present at equilibrium. It is very interesting point. No single reactant cannot escape. No single product cannot escape. At equilibrium, all the reactants and all the products are present. All the reactants and all the products are present at the equilibrium state. No reactant and no product has been escaped. There is no chance to escape the reactants and products. And equilibrium will hold the entire reactants as well as the products. Okay, good. This is very important point also. And see here, if you take the properties like concentration, pressure and intensity of color remains unchanged with time after the equilibrium is established. So once the equilibrium has been established, the color cannot be changed, the concentration cannot be changed, the pressure cannot be changed. Like these properties cannot be changed once the equilibrium has been attained. Once for a reversible reaction, if the equilibrium has been attained, these type of properties like concentration, pressure, intensity of the color, density remains unchanged. Right? They will not be changing at all. Good. Coming to the other important properties. The same equilibrium can be attained by carrying out the reaction starting with the reactants or starting with the products. If you are, yeah, very good morning Lakshmi Mohan. Sayed, good morning. Yeah, maybe reduced. MCET syllabus. Why? Because for AP as well as for Telangana, 30% of the syllabus for IP has been reduced. That's why definitely the MCET syllabus has also been reduced. No doubt about it. It will be reduced and it should be reduced also. Okay. Yeah, it is not mine, Gujarati. It is from Unacademy team. Unacademy team has been reduced my time. Not only my time, all the educators' time has been reduced. So don't worry about that. We will give the complete details in that half an hour itself. We will have only 7 minutes. Please concentrate on the lesson, right? Anyway, Gujarati, thanks for questioning. The same equilibrium can be attained either you are starting from product side and the reactant side. In whatever side you are starting the chemical reaction, definitely the equilibrium will attain. No doubt about it. Okay, if you start from reactants or if you start from products, if you start from any of the sides, the equilibrium will definitely attain. Okay, and it is not a static; it is a dynamic. The equilibrium is not static; it is not in a constant mode. It is a dynamic. Definitely, it will continuous. There is no stopping of the chemical reaction at all. It is continuous and it is a dynamic equilibrium. Right? Good. And see, change in temperature, pressure or concentration of the substance may change the position of equilibrium. Very important concept it is. If you change the concentration of the reactants, other different the state of the equilibrium position will also changes. If you apply the pressure on the equilibrium, definitely the state of the equilibrium will changes. That means it may favor say the forward reaction or it may favor say the backward reaction once you are changing the concentration, pressure as well as temperature. If you change the TPC, temperature, pressure and concentration. If you change the TPCs on the system, on the equilibrium system, definitely the equilibrium state has been changed either towards forward reaction or either towards backward reaction. So if you add a small quantity of reactants or products, the equilibrium will shifts either towards backward or forward reaction. If you increase the pressure, again it will shifts. If you change the temperature also, if you are raising the temperature or if you are reducing the temperature, definitely the equilibrium will shift towards either forward or backward reactions. So, the change in temperature, pressure and concentration of substances may change the position of the equilibrium. It may shift towards either forward direction or it may shift towards either backward direction. Right? And the next one is the catalyst. If you add a small quantity of, you know very well what is the main advantage of catalyst. Anyone please give me the correct answer for the definition of catalyst. What is meant by catalyst? Anyone, please, quickly. What is meant by catalyst for us? Yeah, Anish is there, Pujariti is there, Lakshmi Mohan is there, Adurti is there. So many of you are there. Please, anyone, can you give the complete definition of the catalyst? What is the definition of catalyst? Anyone, please. Good, very good, Anish. It will alter the rate of the reaction. Good. It will alter the rate of the reaction, not simple reaction. It will alter the rate of the reaction. Very good. So it may increases the reaction or it may decrease the rate of the reaction. So catalyst may increases or may decreases the rate of the reaction. If it decreases, we can say that it is negative catalyst. Without undergoing chemical change. Without undergoing chemical change, it will alter the rate of the reaction. Good, very good, nice. See here, if you add the catalyst in any equilibrium state, what will happen? If you add the catalyst into the reversible reaction, what will happen? It does not alter the position of the equilibrium. So there is no effect of catalyst on the equilibrium at all. There is no effect of catalyst at all. Even though you are adding a much more amount of catalyst, no change of the state of equilibrium. But if you change the concentration, pressure and temperature, definitely there is a change of state of the equilibrium. Either towards forward direction it will proceed or either towards backward reaction will be proceed. So reactants will be produced more or products will be produced more once you are changing concentration, pressure and temperature. But if you add the catalyst, it will attain the equilibrium very fast, but there is no change of position of equilibrium at all. Okay. So it only speeds up the attainment of the equilibrium, that's all. But it does not alter the position of the equilibrium, that's all. And the last important one is at equilibrium condition, the free energy change, that is delta G is equal to 0 according to thermodynamics. According to thermodynamics, the free energy change, that means the delta G is always equals to 0 when the chemical equilibrium is to be attained to a reversible reaction. So once the reversible reaction is attained the equilibrium, then we can say that the delta G is equal to 0. That's all. That's all. Is it clear? Is it clear? These are all the important characteristics of chemical equilibrium. These are all the important characteristics of chemical equilibrium. That's all. So after this, our important concept is also over. Right? And you know very well, I have a special class at 6 to 7 alternate days. It will start from Monday itself, and plus classes are also there from 8 to 9:30 every day. 6 to 7 there is a special class, and 8 to 9:30 there is a plus class. Okay, and every alternate days at 10:30 to 11 o'clock there is a YouTube live session from myself which is going on. Good. Then our important concept is law of mass action. Sir, how to manage JEE preparation 2022 with MCET preparation? Yeah, you can manage, Anish. You can manage. Why? Because there is a slight change. Only the application oriented is there in JEE. With respect to JEE, if you take, only the application oriented is there. But MCET point of view, there is no application at all. It's a direct questions will be given. Direct questions will be given in MCET point of view, but the same question will be there with just a twist. That means application oriented will be there. How to apply that particular question? If you know the key point of that particular question, you can crack the JEE also. Just only there is a slight difference. There is a slight difference in between JEE and MCET. You can crack the JEE also once you are listening all. Why? Because we have covered. We will cover also. We have covered and we will cover also the maximum important bits which are very helpful to the MCET as well as which are very helpful for the JEE also. Sir, from when 2021 MCET daily preparation start? Yeah, this is all 2021. See here, Anish. See here, 2021. Right now you can start. It is TS and AP MCET 2021. It is okay. Yes, if you are not taking any subscription, please take the subscription plus a plus course, and so many number of benefits you will have. And suppose if you want to listen my plus class. Yeah, Narayan, good morning, very good morning, Narayan. Already the time is over. It's 11. Narayan, anyway, thanks for coming. Welcome to Unacademy YouTube channel. Anyway, 2022. Yeah, right. Sorry, you are. Yeah, right. Good. Very nice. No problem. You can start from now itself. Okay. You can start from now itself. Why? Because it is for 2021 as well as for 2022 also. Right? Thank you very much, all of you. Thank you very much for kind patience. And once again, thank you for coming to my channel, coming to my session also. Thank you very much. Bye bye. In the next class, we will start the remaining concepts of laws of mass action. Right? Very good. Thank you.